If you drive an electric vehicle, you already know the pain of sitting at a charger for 40 minutes. But you've also likely seen the terrifying headlines of electric vehicles suddenly catching fire and burning for hours. Welcome to Infovision Media. Today, we're tearing apart the anatomy of an EV fire and evaluating the solid-state battery transition slated to begin in 2026. Both the agonizing charge times and the catastrophic fires trace back to a single chemical component inside today's lithium-ion batteries, the liquid electrolyte. To build a car that charges in minutes and resists thermal runaway, engineers are working to remove this liquid from the equation entirely. Inside a standard battery, the liquid electrolyte flows smoothly, but on a fast charger, this river becomes a chaotic flood. Ions pile up violently, creating metallic needles called lithium dendrites that rapidly grow and stab right through the battery's separator. That single puncture triggers an immediate short circuit. Within seconds, the internal battery temperature spikes to a massive 700 degrees Celsius. The liquid electrolyte boils, releasing a highly combustible mix of oxygen, hydrogen, and methane gases. All three of those gases actively feed the flames, creating a chemical chain reaction known as thermal runaway. This is the reason over 500 electric vehicles went up in flames last year, often taking hours to fully extinguish. The engineering fix involves replacing that highly flammable liquid with an impenetrable solid ceramic crystal lattice to carry the ions. This solid lattice structure acts as a mechanical shield. With a shear strength of over 10 gigapascals, it is designed to shatter lithium dendrites before they can ever cross the gap. Without the volatile liquid, there is nothing to boil. Even in a severe collision, the lack of combustible electrolyte makes a traditional battery fire chemically improbable.
The catch is actually making them. Ceramics are incredibly brittle. Stamping out sheets of this material that are 100 microns thin, about the width of a human hair, without cracking them on a high-speed assembly line remains a massive engineering hurdle. Perfecting this high-speed production process will determine which automaker successfully transitions from the laboratory to the showroom floor. Because a solid-state battery doesn't physically degrade under intense heat, engineers can finally unleash the full potential of high-voltage chargers. This chart shows how dramatically the wait times could drop. Today's best liquid batteries take about 35 minutes to go from 10 to 80%. Solid-state prototypes are aiming to complete that charge in just 7 to 12 minutes. We're also seeing a leap in energy density. Reaching 500 watt-hours per kilogram would allow automakers to pack double the energy into the same physical footprint, potentially extending standard ranges to 1,000 kilometers. If you want a 1,000-kilometer range EV in your driveway, hit the like button, subscribe to the channel, and share this breakdown with anyone still stuck at a charging station. These technical specs represent more than a minor upgrade. They are an attempt to push past the physical constraints of current lithium-ion technology. If the technology scales, using a charging stall will feel like a traditional petrol stop. Plug in, grab a coffee, and drive off 7 minutes later. But a 7-minute charge requires a staggering amount of electricity. To fill a 100 kilowatt-hour battery that quickly, the charger must push over 850 kilowatts of power, a draw that would overwhelm many local power grids. To prevent blackouts, stations will need to install massive commercial battery buffers. These units pull power slowly from high-voltage transmission lines all day, storing energy so they can dump it instantly into a vehicle when it arrives. The chemistry is moving forward, but the success of this shift relies on an urgent, large-scale upgrade of our electrical infrastructure. 2026 marks the first year we expect to see these batteries in production vehicles, a timeline reminiscent of the 2012 surge in standard lithium-ion adoption. The world's largest manufacturers are racing to hit this window. Toyota is pursuing sulfide-based electrolytes, QuantumScape is testing ceramic separators, and CATL is readying semi-solid designs. However, market reach will be limited at first. In 2026, solid-state tech will likely be exclusive to premium models costing over $50,000. It may take until the end of the decade for these benefits to reach the mass market. If you are in the market for a high-end EV in 2026, ask one specific question. Does this have a solid-state battery? If the answer is yes, you're at the beginning of the next era in transport. Thanks for watching Infovision Media. We'll see you in the next one.